Hello, chemistry students. This is Sean McMahon, your professor, and this Friday's problem-solving session. I decided to, instead of using uh, a pen and paper, it took me a little longer, but I decided to do a PowerPoint so that this would be a little more legible in this problem-solving sessions. Again, this is Chem 150, Professor Sean McMahon at Miracosta College, and I'm supposed to try to make you feel like you see me all the time. So there I am. There's a picture of me, my profile pic for the course. And I'm picking this problem solving session to do chapter 2, problem 2, 110. So a lot of students struggle with this problem. So I thought this would be a good problem for this week's problem solving session. Again, it is from the third edition of TRO, a molecular approach general chemistry. But in this particular problem, we're going to figure out how many cars can fit in a mole of blueberries, or how much in weight, how many cars weigh as much as a mole of blueberries. So here we go. This is the problem. The mass of an average blueberry is 0.75 grams, and the mass of an automobile is 2.0 times 10 to the 3 kilograms. Considerably more because it's considerably larger. But what we want to know is find the number of automobiles whose total mass is the same as 1 mole of blueberries. So it's a little bit counterintuitive, but how do we solve this problem? Well, we got to go through the basic rules that I talked about. So the first rule, you want to figure out what is it that you're looking for. So the problem tells you, find the number of automobiles. So I want to know how many automobiles there are. Okay, so there's going to be a lot. And why is that? Well, I know that there's blueberries involved, right? But the mass of an average blueberry is 0.75 grams. That's kind of a mass ratio to the blueberries. And then I compare this to an automobile ratio, which is 2.0 times 10 to the 3 kilograms per auto. So both of those are mass ratios. Now, the number of automobiles, that's not a ratio. When I'm looking at a set number, it's not number of automobiles per anything. All I want to know is the number of automobiles in 1 mole of blueberries. So the given is 1 mole of blueberries because it's not a ratio. So I'll repeat, if I don't want a ratio, then I don't start with a ratio. And the average blueberry mass and the average automobile mass are mass ratios, and that's why I don't start with it. Okay, so now that I know what I want and I know what I'm given, how do I get there? Well, I'm given moles. And 1 mole, we know because of Avogadro's number that that's a chemist's dozen. And just like a dozen, when I say I have a dozen eggs, I have 12 eggs. If I have a dozen pencils, I have 12 pencils. Well, a mole is the same. It doesn't matter if I have a mole of ions or a mole of particles or a mole of blueberries. 1 mole is 6.02 times 10 to the 23rd. So what I can do is I can convert moles to the number of blueberries. And that's what that allows me to do. Well, now that I have blueberries, how am I going to get to autos? Well, I know that there's a ratio. I can convert blueberries to grams. And the reason why I can do this is the average blueberry, which is really small, is only 0.75 grams. But I can go from blueberries to grams of blueberries. And now I see that the automobile has a mass ratio in kilograms. So I can convert grams of blueberries to kilograms of blueberries. How? Well, I can use the metric system. I know that there's 1,000 grams in 1 kilogram. And now that I have kilograms, I see that I can use, well, there's 2.0 times 10 to the third kilograms per automobile. So from kilograms, I can convert that to the number of autos in that mass ratio. So what does that look like? When we set up our conversion factors, it looks like this, right? So we have 1 mole of blueberries, And in 1 mole of anything, there's 6.02 times 10 to the 23rd blueberries. What does that do? Cancels out the unit of moles and leaves me with the number of blueberries. And now, in the problem, I see that the average blueberry is 0.75 grams. I can use the next conversion factor to cancel out the number of blueberries and get the unit of grams of blueberries. And then from grams of blueberries, I can use a metric system. There's 1,000 grams in 1 kilogram of blueberries. And then I could use my other mass ratio in the problem and convert kilograms to autos. And that's because there's 2.0 times 10 to the 23rd kilograms in one automobile. And I see all the units cancel, and I'm left with the unit of automobiles. So how many autos? 2.3 times 10 to the 17 autos. Remember, after you perform the calculation, you have to have the right number of sig figs. Why are there only 2 sig figs here? Well, if I look, 1.0 moles, that's 2 sig figs. So my final answer has 2 sig figs. So there's a lot of automobiles, right? Even though they're way heavier than blueberries, there's a lot of automobiles that would require to be the same weight as a mole of blueberries. And why? Remember, the mole's a huge number. The difference between 10 to the 17 and 10 to the 23rd is 10 to the 6, which is 1,000,000 times bigger. So I hope you guys enjoyed this edition of problem solving session for Chem 150. And yeah, I'll see you next time. Thanks.